Okay, so that's a Poisson distribution, and what are you going to work with a Poisson distribution? What are you interested in? Suppose, for example, we have a limited number of values that this Poisson distribution can take. We then observe something, and we want to create our table. So this is like the table that we did in last week's practical. So we start off, we say, suppose I can take values of lambda that are 1, 1.5, 2, and 2.5. Again, these discrete examples do tend to be slightly artificial because they're showing about the process of how this is done. In reality, we tend to go to the continuous case, which is these become integration, and you have to do this technically at every point, but you don't. And suppose I was to say that the middle two cases, so the middle two, were judged to be twice as likely to occur as the two other edge cases. What would be my prior distribution here? So 1 and 2.5 have equal prior probability. 2.2 and 1.5 have equal prior probability, which is twice that of 1 and 2.5. Yep. So we have 1/6, 2/6, so that's a third, and 1/6. Okay. And now you're told, I've observed y equals 2. So I did kind of an experiment, and I observed a count of 2. And I want to, based on that, to update what's my best guess as to the value of lambda. So first thing you write down is your likelihood. Given that y equals 2. So that's going to be lambda squared over 2 times e to the minus lambda. Yep, happy enough with that? It's just replacing y with 2. 2 factorial is 2. So we get lambda equals 1 into this equation here. So we get a half e to the minus 1. Lambda is 1.5 into this. So you get 1.5 squared over 2 e to the minus 1.5, which is 1.125 e to the minus 1.5. 2 squared is 4 divided by 2. E to the minus 2. So you get 2 e to the minus 2. And finally, 2.5 squared divided by 2 is 3.125 e to the minus 2.5. This is our reduced universe. It's what we've seen, what we're interested in. Everything else kind of irrelevant because it hasn't happened. So the next thing, so we have our prior and we have our likelihood. What's our next thing we do? Times them. Yep, prior times likelihood. So we get, this is 1/12 e to the minus 1. This is 3/8 e to the minus 1.5. 2/3 e to the minus 2. And 25 over 48 e to the minus 2.5. Now what do we do? Yeah, so to calculate the posterior, these are the general weights, but is this a probability density or probability distribution? Why isn't it? What do they not do at the moment? Add up to 1. So to turn it into a posterior, you divide by sum of the previous column, which I've done this already and I checked it out. It was 0.247366. So you divide e to the minus 1 over 12 e to the is by this is 0.124 to 3 decimal places. Just going to 3 decimal places here is quite sufficient. 38, 0.365 and 0.173. And if you were doing this in an exam, 3 decimal places is plenty. It's showing the principle of, you know, how it works is what we're assessing rather than the individual little values.